So, good afternoon, everyone. I think we should try and start on time because we have a busy agenda. My name is Stephen Briggs. I have the honor to be the chairman of the steering committee for the Global Climate Observing System, GCOS, and I've been asked to chair this event, which is an integrated event. We are talking about integrated observations, but we've also integrated some of the observing systems. So we have not only GCOS here, but also the Group on Earth Observations, GEO, and the Japanese Research and Technology Agency, RESTEC, which has a particular interest in greenhouse gas monitoring, which you'll hear about later. So we're very pleased to be able to come together to tell you a story about the needs for observations and what we're all doing post-Paris. Now, Paris was seen as a great success, and indeed it was, but it was really the beginning of the story of the needs for greater observations to understand climate change, but also to look into the consequences and the mitigation and adaptation. And although we hear very much about 1.5 degrees and 2 degrees coming out of the agreement that was made in Paris, there's also a great deal in the agreement about the need for better information for adaptation, for loss and damage, financial aspects, and a whole range of different requirements which are quite clear there in terms of better information about the Earth system. And that information is very broad. It's not just about the physical climate. It's also about the biology of the Earth system, about the social, economic, anthropogenic aspects of life on Earth. And bringing all these together requires a very broad range of different types of information which are supplied by a broad range of different agencies. And some of those are here today, and three of us today are here to present the interests of those bodies. So firstly, welcome to you all, and I hope that you're going to find from the range of different presentations, which is very broad, the breadth of the requirements and the breadth of the systems which are in place in order to try and deliver the observations which are needed to provide an integrated solution to the requirements coming from the Paris Agreement. So I'd like to introduce our first speaker, which is Andrea Tilcher, who's head of the climate unit within DG RTD in Brussels in the European Commission, and I would like to invite Andrea to give us some introductory remarks.
Thank you, Stephen, and allow me to welcome all of you as well today at this GCOS RESTEC side event at COP23. I do it on behalf of my Director General, Robert Jan Smits, who has been in the last year the lead co-chair of GEO, and just 1 week ago handed over to our US colleague co-chair. GEO is a partnership of 104 member states plus the European Commission and 111 participating organizations, has the goal to implement the global Earth observation system of systems and has been working for already 12 years now to improve the availability, access and use of Earth observation data for the benefit of society, promoting open access and interoperability. GEO selected 3 global priority engagement areas for its work: the support to the UN Agenda for Sustainable Development, the Sendai Framework for Disaster Risk Reduction, and the Paris Agreement on Climate Change. On the latter, the partnership with GCOS and with the agencies, the space agencies in particular, is essential to enhance global observation systems, to help strengthening resilience and to improve monitoring and prediction. The European Union is contributing massively to this endeavor, in particular through the Copernicus program and the Framework Program for Research and Innovation. Copernicus, which is the major contribution from Europe to GEOS, is already providing open and free access to data and services of relevance for climate, and through various services: the climate change service, the atmospheric service, the ocean service, the land one, and even the emergency service recently during the hurricanes Harvey and Irma has provided continuous flow of images and maps of the damages of the affected regions. In our framework program for research and innovation, Horizon 2020, we will invest about 1.1 billion per year in the next 3 years on the support to the Paris Agreement. And in a specific focused area of research that we have called building a low carbon climate resilient future. And within this context, we have already launched and we will further our activities in the next 3 years in new key research activities in support to the Earth observation aspects. We have launched EuroGeos, the European component of GEOS, and various related climate-related observing systems. In particular, we will work a lot in the next few years on the Arctic. And within an ambition joint program that sees various components internationally participating, such as the Japanese one, and we will hear today from that, to develop a Copernicus global capacity of greenhouse gas observing. This will offer all parties of the convention better capabilities to monitor the national efforts to go towards the mitigation objectives and to contribute to the transparency framework of the Paris Agreement. We put a lot of importance in this endeavor that has to be seen really in this perspective. All this is part of our commitment within GEO to work and to implement the global Earth observation system of systems. And I'm really pleased that we can hear today more about the integrated observation for mitigation adaptation and how to support practically the parties from a outstanding panel of experts that is here today with us. So I wish all you a good listening to this event.
Thank you very much, Andrea. So now we come to our first speaker for this afternoon, and there's probably no one personally who represents the integration of observations better than Paul, who has been a great supporter on behalf of Germany for both GCOS and GEO over the years. So I'm very pleased to have Paul Becker here to talk to us about the national implementation of GEO and GCOS in Germany. Paul.
Yeah, thank you, Stephen. Thank you, Andrea. Dear colleagues, ladies and gentlemen, it's my pleasure to introduce you today how Germany is handling GEO and GCOS related activities in support of mitigation and adaptation to climate change. In other words, the idea is to give you a flavor of what is going on regarding GEO and GCOS and climate change in Germany. As you may know, the group of Earth observation is organizing its tasks around 8 social benefit areas which determine the data needed for. And the 9th SBA is climate, which has to be considered with the 8 other SBAs. And climate is a cross-cutting issue, and this is where GCOS comes into the game. I will talk about this in the second part of my presentation. And as you may know, in 2016, the 17 SDGs of the 2030 Agenda for Sustainable Development official came into force. And of course, Earth observation being taken in situ or by remote sensing techniques for many SDGs can help to achieve the goals set for the next 15 years and monitor the implementation. And I've tried to indicate which SBA likely supports which SDG. And you can see this. It's obvious that GEO supports the number 13, which is climate action, in many ways. And I want to give you some ideas why Germany is engaged in GEO, why we are interested in GEO. There are 4 main reasons why Germany is engaged in GEO. The order you see on the screen is not necessarily indicates our priorities. First, Germany is contributing to Earth observation programs and initiatives with data, methods, and services, and we therefore are interested also to contribute to the international coordination activities like GEO. Second, I believe it is advantageous to use international coordinated data and methods for our national purposes. Thirdly, there's always something to learn from international partners, but this might be also true vice versa. And fourth, we eventually also benefit from the momentum created by GEO, e.g. with regards to data policy. And Germany is engaged in GEO from the very beginning. In Germany, the implementation of GEO and GEOS is a top-down process led by the Federal Ministry of Transport and Digital Infrastructure. A German GEO working group has been established that meets about 3 times a year. And each time we visit another institution relevant to GEO, hoping to find new partners joining the group. And besides the regular meetings of the German GEO working group, a national GEO implementation plan has been developed, implemented through an annual work plan. And through the German GEO working group, we try to stimulate and identify funding opportunities. And we are very close, working close together with our European partners like ESA, EUMETSAT, and Copernicus. As already mentioned, the activities of GEO can play an important role in meeting the SDG goals or in monitoring the implementation. And this is especially true for the SDG 13, climate action, which is closely linked to the UNFCCC process and the Paris Agreement. In this context, as an example, reforestation can be used to extract CO2 from the atmosphere for a long time storage in the ground. In this context, Earth observation from satellite can provide data to monitor the development of the national forests, especially in areas that are otherwise difficult to access or even inaccessible. Therefore, GEO has initiated the Global Forest Observing Initiative, GFY, to support the REDD Plus countries. REDD Plus stands for Reduce Emissions from Deforestation and Forest Degradation in Developing Countries. And Germany, as one of the major REDD Plus donors, has a natural interest in a well-working and consistent REDD Plus monitoring reporting system. My second example is the sustainable urban development. It is clear that in a country with more than 75% of its population living in cities, it is highly relevant from a user perspective to know and understand the special meteorological and climatological features of densely populated areas. Such features include the well-known heat island and winter effects, but also impacts from heavy precipitation. We are now working towards an urban observation network to improve our observational knowledge of urban climate and its changes over time. While finding new observation sites in city centers is not always easy, we at that time also make use of new means of gathering our data. In this picture, we use a tram which measures temperature and humidity profiles. And I can also imagine to use citizen science in order to enhance the observation density. As we know that climate will be changing in the future, and as we are able to model the impact of increasing temperature on the urban heat island, here shown for Frankfurt, we can calculate these changes for individual cities. Shown here is the number of days per year with more than 25 degrees centigrade, and as you can see, the number of such days will double or even triple compared to present time experience. Knowing this allows city managers to adapt their plans accordingly. At this point, please allow me a short announcement for a side event on sponge cities, how cities can adapt to climate change that will take place in the German pavilion next Monday from 1:30 to 2:30. As already mentioned, climate is a cross-cutting issue for all GEO benefit areas, so societal benefit areas. And GCOS has an important role. GCOS is, so to speak, the climate-related observation part of GEOS. And now let's have a very, very quick look on how GCOS is being implemented in Germany. GCOS has been established in 1992, and it itself is a system of observation systems. GCOS is coordinated by a secretariat that is jointly sponsored by WMO, IOC from UNESCO, UNEP, and ICSO. And one of the GCOS success stories was the introduction of the concept of the essential climate variables, ECVs, now also be used by other communities. And Germany was among the first countries to establish a national geo-secretariat and a national GCOS coordinator. The following slide will shed some light on the many ways Germany is supporting GCOS. The first two bullets gives you an overview on GCOS observing sites operated by German institutions, and the other 7 bullets shows you the data and product centers operated in Germany that contribute to GCOS. And in 2013, we summarized our activities into an inventory report on the GCOS in Germany, which is available online and scheduled to be updated in 2020. One specific example of Germany's contributions to GCOS I would like to mention are the Argo floaters, which allows us to get vertical profiles from the ocean. And we have been successfully in having this activity integrated in our regular budget. We have more than €500,000 per year that the Federal Maritime and Hydrographic Agency is able to deploy about 35 floats every year. And what will happen next? What is important for me? To enhance the accessibility and interoperability of the data, to work towards sustaining critical observation infrastructure, implementing GCOS implementation plan 2016 in Germany, and what is very important is to develop an operational, more or less operational greenhouse gas monitoring and information system. And with 2 sentences more, I will stop. What I want to say is we as Germany are convinced that GEO and GCOS are very important players regarding mitigation and adaptation to climate change. And we as Germany will do everything we can do to strengthen these roles. Thank you very much.
Thank you very much, Paul. We will take discussion and more general questions later, but if there are specific factual questions to Paul, I take 1 or 2 now, but I trust there are not, in which case we can move straight on to our second speaker, Juri Haskainen from Finland, and he will talk to us about the Integrated Carbon Observing System, a program which has been set up in Europe, but which also forms an integral part of other broader activities inside GEO and GCOS. So, Juri, thank you.
Thank you, Stephen, for the introduction. So, I'm happy to give a presentation on behalf of Integrated Carbon Observation System. My name is Jouni Heiskanen, and I'm talking about regional observations, and it's quite natural because ICOS is regional in Europe. But I will start from a figure or graph which is quite familiar, I guess, to many of you. It is provided by Global Carbon Project. On the left-hand side, there are the sources of anthropogenic carbon dioxide emissions. The biggest one of those is fossil fuel emissions. Then on the right-hand side, there is the natural sinks of this carbon, and the biggest one of those is the atmosphere. The other 2 components are the terrestrial ecosystems and the oceans. But I have now reshaped these components there. So I have taken the atmosphere on top there, and then on the bottom there are these natural sinks, and in the middle are the anthropogenic sources. The idea behind this is, of course, that the carbon dioxide first goes to the atmosphere from these human-made sources, and then it is taken up by the natural sinks. On top of this, now I have shown this natural carbon cycle. So on the left-hand side, there's a global cross-primary production, which basically means that the carbon that is taken up by primary producers, so plants living and growing, they take up the carbon. On the right-hand side, we have global respiration, which is basically when you can think it as when living things exhale, they exhale carbon dioxide to the atmosphere. And those are now the natural processes on top of that, and the magnitude is quite much larger than the human-made emissions. Now I modified it so that the fossil fuel emissions come there on right-hand side, on top of the global respiration. Part of this extra carbon dioxide emission is staying in the atmosphere, but part of that is going into the natural sinks. We are seeing a lot of discussion of fossil fuel emissions in the press and in the news, but also what is actually quite important is that how these increasing carbon dioxide concentrations affect to these natural processes. At the moment, we could compare it to playing a roulette. We have quite many different results on how increased carbon dioxide affects the natural processes. Some studies say that the respiration gets lower. There might be drought coming or more rain, heat waves and so forth. And if you really want to know that what happens to your country or your region, we need to have systematic observations. And that is where ICOS kicks in. We are doing these in situ, so ground-based observations. It is a European infrastructure. It is a distributed one. We have over 100 measurement stations in different scientific domains. That means that we are measuring concentrations in the atmosphere, fluxes from the ecosystems, and also from the oceans. And what we are actually doing with these different sources of data, we are bringing these together. So these are different scientific communities with different kind of methods of working with the data. What we are doing with those, that we are making them interoperable so that these data can be easily compared to each other from different stations. We are pooling it to a single source where we are distributing the data. It's a web portal called ICOS Carbon Portal. All the data is freely available from there. But it's not only data that is the main interest for the scientists, but it's also data products. What we mean by that is, let's say, emission maps, regional maps of emissions. We can provide those. We can provide reports and so forth. So we are making this as utilizable as possible, and these are ICOS services we are providing. But it's not only that. That's one part of the big picture. So we have the in situ ground-based observations. That tells part of the story, but we also need satellite observations. We need modeling. Now with ICOS, we have measurements and information from these stations and around them, but we really want to understand also what happens between the stations. For this, we need satellites and modeling. When we combine all these different scientific approaches, we get the bottom-up estimates of what happens there in the ground, at grassroots level, and then also we get the top-down estimates when looking on top of that, at how things go. This really helps us to understand the emissions and sinks regionally more better. But again, that was only regional approach. When we look at the whole globe, there are actually quite many actors working on different parts of this big picture. ICOS is part of that. As you can see, there are quite many other players there. And this is not even all of them, but this gives you a picture of how distributed it is. It is regionally distributed, and it is distributed also with the scientific methodology and the parameters that are measured there. Well, luckily for us, there has been a lot of development in this region with geocarbon and greenhouse gas initiative. The aim of this is to globally coordinate these observations. ICOS sees high value in this initiative and is supporting it. It's supporting it with data, with the expertise we have, and also we are hosting the Geocarbon Secretariat. Geocarbon is aiming to be a lot bigger than only working with the data and information flows there. The idea is to focus on the whole chain from observations all the way to the decisions. There is knowledge in between. There are services also that we provide. Now I have distributed different actors on this kind of groups, from data providers to coordinators and so forth. And as you can see, there are some familiar institutes, organizations there, but certainly many of these are operating in quite different or quite many of these domains here. And this just tells us that the picture is quite complex. But nevertheless, this is something that we really need to do, that we cannot anymore only focus on data provision, but we need to get also to the user-specific services that we can provide. And this is also important for ICOS. And geocarbon is this framework in carbon and greenhouse gas observations that we are trying to fill this whole link here. So basically this means that we don't want to play roulette with our future, but we want to provide the best possible information and services for the decision making and actions in different societal sectors. Thank you.
Thank you very much, Yuri. It gives a very good example of the complexity of the problem of looking at the global carbon system and the different elements which need to be integrated into that. And thanks very much for that perspective. Now we'll come to a slightly different aspect, and with two speakers from Japan here. The first of these, Kyoto Tanabe, will be talking to us about the development of the IPCC guidelines and the current status of the updating of those guidelines, which will be very important for us to understand in terms of future reporting on the greenhouse gases. So over to you, please, Kyoto.
Thank you very much, and good afternoon, everyone. I'm Kyoto Tanabe from the IPCC Task Force on National Greenhouse Gas Inventories, and I'm going to talk about the ongoing work by the Task Force on Inventories about the refinement of the IPCC inventory guidelines. All the parties to the UNFCCC have an obligation to prepare and report their national greenhouse gas inventories. And they have been using the IPCC inventory guidelines to prepare their own national greenhouse gas inventories for many years. And so far, for more than 20 years, IPCC has been trying to improve the inventory guidelines, taking into account the up-to-date scientific information and data. But the last comprehensive revision update of the inventory guidelines was in 2006, that is more than 10 years ago. So some part or some information, some data included in this 2006 IPCC guidelines are sort of already obsolete or outdated. So the IPCC has decided to work to partially refine this 2006 IPCC guidelines recently. And now we are in the process of producing that new report to refine the 2006 IPCC guidelines. The name of the new report will be the 2019 refinement to the 2006 IPCC guidelines for national greenhouse gas inventories, because this report will be expected to be published in May 2019. The overall aim of this project is to provide an updated and sound scientific basis for supporting the preparation and continuous improvement of national greenhouse gas inventories by all the parties to the UNFCCC. But we are always careful in calling this report as refinement, not revision, because this report is not intended to fully revise the current 2006 IPCC guidelines, but it's intended to update or supplement or elaborate the guidance included in the 2006 guidelines. That said, this report is now being developed by approximately 200 authors from all over the world, and we will go through 3 review stages that will be open to experts and governments in the world. Okay. Then satellite data or Earth observation data, because Earth observation data, I think that is Earth observation is the main theme of this side event. So I would like to focus on satellite data or Earth observation data, how those data are used in the IPCC inventory guidelines. In the current 2006 IPCC guidelines, use of Earth observation data or satellite data are referred to mainly for the two purposes. The first is for verification of emission removal estimates of greenhouse gases. And the second is for collection of activity data for agriculture, forestry, and other land use sector. More than 10 years ago, when these guidelines were developed, already Earth observation data were mentioned in these guidelines. But actually, there is no detailed discussion or guidance. We couldn't include such detailed guidance in the 2006 IPCC guidelines because at that time, more than 10 years ago, there was no sufficient information or data that can support a robust, detailed guidance to be included in the guidelines. Verification in inventory community. The word verification refers to activities and procedures to help establish the reliability of greenhouse gas emission removal estimates. And for this purpose, for example, comparison of the emission estimates with atmospheric measurements. That is one of the options to do this. And that was mentioned in the 2006 IPCC guidelines, more specifically, for example, use of inverse modeling with satellite-borne sensors for greenhouse gas concentration measurements. That kind of option was mentioned in the 2006 guidelines, but as I mentioned, no detailed guidance could be included at that time. Sorry. The second purpose of use of Earth observation data was as I mentioned, for collection of activity data for so-called AFOR sector. Use of remote sensing data explicitly referred to in the 2006 IPCC guidelines as a means to, for example, obtain maps of land use at regular intervals, or estimates of changes in carbon stocks in above ground biomass, and so on. But again, at that time, more than 10 years ago, there was no sufficient scientific information or data that can support robust guidance to be included. Therefore, only a brief mention was made in the 2006 guidelines. And now we are working to refine the 2006 IPCC guidelines, and thanks to the advancement thanks to great advancement, I would say, in the Earth observation community, technologies, remote sensing technologies, and so on, and great advancement of that kind of technologies. Thanks to that. We believe that one of the areas that can be greatly improved in this work will be about the use of Earth observation data. So in the new report that will be published 2 years later and being developed now, in this new report, chapter on quality assurance and quality control and verification will be updated and or elaborated, referring to the use of Earth observation data. Also, chapters relating to collection of activity data for AFOR sector will be updated or elaborated, or where necessary, new guidance will be added. Mentioning or using the application of Earth observation data for this purpose. So these improvements will be made in the upcoming 2019 refinement to the 2006 IPCC guidelines. And this work by the IPCC TFI was already welcomed by the Substar. Substar in May this year, they welcomed our plan of this work, and also the Substar at that time noted this work by the IPCC may well inform the discussions under the agenda item on the revision of the UNFCCC reporting guidelines on annual inventories for annexation parties. So the Substar, to my understanding, is waiting for the completion of the 2019 refinement. And after completion of that report, Substar, I hope, will consider how to apply, how to use that new report for inventory compilation. And this report is being developed, and the first order draft will be coming soon. And that first order draft will be subjected to the first review. We call it expert review, because this review will be done by experts from all over the world. And any expert who have relevant expertise can participate in this expert review. This review will be taking place from 4th of December to 11th of February, and anyone who have relevant expertise can register through the internet. And the online registration site will be opened for from 20th of November to 4th of February, so please participate in this review. Draft reports, first of the draft, cannot be publicly distributed or quoted or cited, but you can get it by registering yourself as an expert review through the internet. So please try to do that, and we are very much looking forward to your comments. So please join us in this exercise. Thank you very much.
Thank you very much, Tanabe-san. So for those experts there, please help support this activity in the coming months. Now, Tanabe-san has given a very good introduction through his description of the way that satellite data have increased to be able to support the IPCC guidelines already. So I really need no further introduction than to our next speaker, who will speak about the way that satellite observations can now increasingly support national greenhouse gas inventories. So over to Masanupa Kimura. Thank you very much.
Good afternoon, ladies and gentlemen. I am Masanobu Kimura, Director of Research and Information Office of Ministry of the Environment of Japan. Today, I would like to introduce Japan's satellite project for monitoring greenhouse gases globally, called GOSAT, and our activities for the data utilization for the Paris Agreement. Japan has developed and operates the greenhouse gases observation satellite called GOSAT that monitors the concentrations of major greenhouse gases such as carbon dioxide and methane on a global scale. GOSAT was jointly developed by 3 Japanese institutions: Ministry of the Environment, the National Institute for Environmental Studies, and the Japan Aerospace Exploration Agency. The satellite was launched in 2009. Since then, we have collected and analyzed huge amount of data with specific analysis approach on global greenhouse gases concentration and get various scientific findings. For instance, a recent analysis of GOSAT observational data has revealed that the whole atmospheric monthly mean CO2 concentrations exceeded 400 ppm, and methane concentration exceeded 1,800 ppb. And anthropogenic or natural-based. It can be identified by their concentration levels in the atmosphere measured by GCOS. This has opened up the future possibility of the satellite to be applied as a tool for monitoring and verifying the national greenhouse gas inventories. GCOS has already exceeded its design life of 5 years and has been operating more than 8 years. In order to continually monitor greenhouse gases, Japan started developing GCOS-2, a successor of GCOS in 2012, which is scheduled to be launched in fiscal year 2018. GCOS-2 is designed with strengthened function to find out the behavior of global greenhouse gases with even higher accuracy and density. GCOS-2 has the function to automatically detect and avoid clouds, which will become an obstacle for measurement from space. And also, GCOS have the function to enable measurement of carbon monoxide concentrations to identify the concentrations of anthropogenic CO2 more accurately. Now I'd like to talk about a project for contributing to Paris Agreement, the implementation of Paris Agreement by utilizing GCOS. Under the Paris Agreement, all parties will be required to regularly report on their greenhouse gas emissions and their implementation efforts in a common and flexible manner. These reports will be subject to the reviews in which transparent examination will be essential. We consider the satellite observation data can be used as monitoring and comparison tools for greenhouse gas emissions. As Dr. Tanabe mentioned, the Intergovernmental Panel on Climate Change will refine guidelines for national greenhouse gas inventories to estimate emissions in 2019. Japan is aiming to add descriptions of the use of satellite data for comparing them with greenhouse gas inventories in the refinement of the guidelines. We'll also publish a guidebook to provide overview on satellite remote sensing of greenhouse gases and their application for verifying greenhouse gas emission inventories. Moreover, Japan is considering to conduct a training program for practitioners engaged in greenhouse gas inventories on usage of satellite greenhouse gas data for verifying greenhouse gas emission inventories by their own. Ministry of the Environment of Japan will maintain the continuous greenhouse gas monitoring by GCOS-3s and collaborate with other countries to contribute for reducing greenhouse gas emissions. Now, finally, I'd like to talk about the way forward of the GOSAT project. GOSAT 2 will be launched in fiscal year 2018. We will develop methodology to estimate anthropogenic GHG emissions and removals with satellite. We'll input to IPCC greenhouse gas inventory guidelines to enable all countries utilize GOSAT data for comparing with national reports on greenhouse gas emissions. We'll promote training practitioners engaged in greenhouse gas inventories and accounting in developing countries with the guidebook. We will collaborate with other countries for monitoring greenhouse gas emissions. So that's the end of my presentation. Thank you very much for your attention.
Thank you very much, Masanobu. So from the perhaps more advanced aspects, of observing the different elements of the Earth system from space, and the increased role that satellites will continue to play now more and more in supporting greenhouse gas inventories, we come to the last part of our title, which was about practical implementation and practical support to parties. And we have two talks now which are going to address those particular points. And the first of these is from Tim Oakley, who is going to talk about the GCOS cooperation mechanism, a mechanism for supporting countries in reporting in terms of providing climate observations from their local territories. So, Tim.
Thank you, Stephen, and good afternoon, ladies and gentlemen. Yes, a slight change, I think, from the first four talks, really going into some of the more practical parts of work in terms of trying to support observations for mitigation and adaptation. And I'm not going to go into any detail and explain GCOS to you here. I'm really going to focus on one very specific but very significant component of the GCOS program, which is called the cooperation mechanism. My name's Tim Oakley. I come from the Met Office in the UK, but I've been seconded working for GCOS for the last 4 or 5 years, working in the WMO offices in Geneva. And I mean, just to show where the cooperation mechanism came from, I mean, it's been running now for more than 10 years, and it was established to identify and make the most effective use of resources available for improving the climate observing systems, particularly in developing countries. And it's you'll see as I go through the talk here, we very much are focusing on the developing countries here and how to help them with their observing systems. And pretty much since 2005, I mean, to give you an idea of the scale here, we've talked about $3 million has gone through the mechanism in support of projects. And some of you would know that GCOS has come up with a new implementation plan which came out last year, and this went on to show the fact that the need for this type of capacity development and the mechanism is still going on to assist developed countries to maintain or renovate climate observation systems and to improve their networks. And there's a whole list of text here in the implementation plan that goes about how and who we are trying to target here to help fund and improve these observations. And lastly here, coming a bit to me, GCOS has a dedicated network manager. I provide both technical and skills to manage the program. I monitor the performance of the networks. I support and work with National Met Services to help them to understand the challenges and the capacity they need to run the networks. I actually have a few projects that I actually manage. I give advice to the program and I do outreach. And pretty much I'm funded on a 1 to 2 year basis in support of this work, both funded through the Trust Fund, but also with the support of the UK Met Office. And to give you an idea of the sort of or the broad range of work we get involved with here. You can see here some pictures of the work that's gone on over the last 5 years. Some of the work will get very much just involved in technical, funding consumables, buying instrumentation. We get involved very much in training of staff. The top two to the right pictures are where we've undertaken training workshops in doing upper air observations and training technicians in the support and the maintenance of the equipment. And then along the bottom we have the fact that we're very much working in some of the more traditional observing. I mean, we've had talks about satellite and remote sensing here, but very much we're going back to some of the basic observations here of surface observations and radiosondes launched from balloons. And these are still, and I think when we come on to the second talk, you'll see these are very much still the underpinning observations that go into traditionally to weather forecasting and the big NWP models, but more and more these are being linked to climate services and adaptation and mitigation. And in the bottom right-hand corner, we get involved in even the telecommunications. Sometimes making the observations is not actually the biggest challenge. It's actually getting those observations out of the countries to be used by the various users. And this plot shows you a range of areas where we've worked in 2016. Traditionally, as I said, we've supported observations and looked in Africa to the developing countries, but you see that we're not necessarily confined to those areas, and actually now, as financial challenges sort of face all of us, there's a number of countries that find it challenging to actually fund the observation. So the pictures with the balloons is where we've supported the more upper air observations, but we also get involved in other types of techniques and needs. And what I will do now is I'll just show you three very specific examples of the work that we've been doing in 2016. So the first example is where we did work starting in 2016 to help with surface instrumentation. When you go into Africa, these pictures on the left are actually very typical examples of the challenges of making the observations and the types of equipment they're still using. I mean, we're very much coming from my world in Europe. We tend to see very modern equipment, but here we're still looking at some very simple and fundamental observations being using just the thermometers, very little electric, very little modern equipment. And here we went into Chad. We did a review of the sites. We wrote what I call a very simple specification, just focusing on the requirements. And we came up with a solution which was more automated, but still very much used the local observer. And this system was installed in 2017 in March. And you can see here a much more modern piece of equipment, easier to maintain. It has digital readouts, uses solar power and things like that. But very much it still needed the observer to make sense of the observations, to make and send the observations back to the headquarters. The second example is the radiosonde observations. These are still, I mean, although for many years people have said that satellites are sort of replacing a lot of these observations, the radiosonde observations is still very much an underpinning technology, and it's still used at 800 to 900 radiosonde stations around the world. But they are expensive systems to run in terms of the consumables. So here we went into Nairobi with funds kindly donated by Switzerland. We upgraded the ground system using a very generic specification. We did a competitive tendering, which tends to get the best price for the radiosondes, and the system was installed in September 2016 and came operational by the end. And the final example is data rescue. We still very much recognise the importance of historical data, and that picture on the far left-hand side is again a very typical picture of a number of Met services where they have rooms full of paper and documents with records going back sometimes 100, 150 years. So with very simple projects, and this was actually funds kindly donated by Germany, we went in and provided a system of archiving, shelving, logging, scanning the pictures and things like that. And something like this, which is relatively low cost, can show very significant benefits. And in a workshop in October of last year, very much showed the improvement of what went on. So in summary, I think the GCM projects, we very are able to demonstrate the benefits of climate observing systems, particularly in Africa, but we've also shown the fact that we can work in remote locations. In the past, we've helped many of the small islands in Galapagos and the Cook Islands and Maldives. So we're not just focusing on Africa. We can work in other regions. But these, as ever, the extent of the benefit is limited to the resources available. And with limited funds coming into a trust fund, you very much become reliant on more reactive funding, because basically you just have limited resources available. Africa remains by a long way the worst performing region according to our monitoring, and that's where we tend to target most of our projects. And at the moment we have funds needed in excess of $1 million to support national services. And whilst sustainable solutions are always our focus, this is reliant on an ongoing commitment from the countries. At the moment, most of the funding tends to be very singular infrastructure or one-off payments. Doesn't always go that way to provide long-term support. But we tend to find that we have technical support, but the funding isn't always there. And that's the end of my talk. Thank you.
Thank you very much, Tim. So it's very good to see that though we have very high ambitions and sometimes some grandiose plans, we still have our feet very much on the ground in terms of the implementation of some aspects of the GCOS plan. Our final speaker had the fortune not to be virtually in Fiji as we are today, but actually in Fiji a few weeks ago, and he's going to report back from some work that was done there for local measurements and local observations for the upper atmosphere in a joint program in Fiji. Thanks very much, Simon.
Thank you very much. Yes, I'm going to talk a bit about the regional workshop we held in Fiji. This has its origins in the GCOS implementation plan that was submitted to the COP last year. And in the subsequent decision by COP, which asked parties to work towards the full implementation of the plan, and the subsequent conclusions actually highlighted the need for these regional workshops and encouraged us to go ahead and do them. So we held the first one recently in Fiji. We had representatives from, I think, all the island states highlighted on the map, and it was held jointly between GCOS and the WMO Integrated Global Observing System, because a lot of the observations we make and on need for climate are also useful for numerical weather prediction. The meeting itself was hosted by the Fiji Meteorological Office and was supported by the Secretariat of the Pacific Region Environment Programme, and I think that local support very much contributed to the success of the meeting. We decided to focus the meeting on two areas. I think initially, for this was the first of the regional workshops, we wanted to be quite focused on particular topics to try and get meaningful results. The first is the upper air measurements. We heard quite a bit from Tim about radiosonde measurements. These are systematic upper air measurements lead to global benefits. They actually underpin a lot of forecasting and climate reanalyses, which themselves form the basis of much of the understanding of climate and climate change and climate prediction. These sort of observations in the Pacific region are thought to have the highest impact of all ground-based measurements on the global quality of weather and climate analysis and prediction. And so it's important to remember that while we're talking about countries making observations in their own territories, these are actually measurements that have global benefits for us all. And it's obvious that the spatial density and observing frequency currently fall short of both the GCOS and WMO requirements. And they're also beyond the resources of many of these small island states. The other topic we looked at briefly was precipitation. It's clear again that changes in extreme events are significant impacts of climate change, and water-related issues are significant adaptation challenges for most countries. So we thought we'd try and look at that as well. The Pacific Islands themselves have a number of challenges, which I'm trying to summarise in this plot. At the bottom I got the USA and Japan for comparison. And if you look at the areas of ocean for which they claim some responsibility or might be expected to monitor, the amount of ocean compared to their GDP or population, if you look at the last two columns, is vast compared to either the GDP or population. So they have significant problems in actually looking at these areas. We're looking at a large area of the planet with very little land. The meeting itself came up with some interesting findings. For the upper air measurements, many of the upper air measurements have ceased. The only ones now operational, apart from those in Fiji, are those with external funding. The main reason for stopping these observations is the lack of resources for consumables and maintenance. It's the ongoing operational funding that's the main issue. Precipitation, it was clear that precipitation measurements may not be representative of many, especially for the volcanic islands, where they might not address the range of rainfall you get across an island. There are also islands where there are few or no measurements, which is particularly important considering the issue of drought, which affects several of the parts of the Pacific. The remoteness of the islands can increase the costs, it makes maintenance more difficult and exacerbates communication issues. And procurement was also, obviously this was an issue with the lack of expertise and the relatively small quantities in remote locations, all increasing the costs and difficulties of procurement. And finally, there were a number of capacity building needs to be addressed. I mentioned the importance of upper air measurements. This is simply a quote from the Deputy Director of ECMWF talking about radiosondes in Papua New Guinea, where he says about how these measurements and ultimately affect the ability to predict weather in Europe. And he points out that isolated radiosondes are individually more important and more valuable than when they're part of a more dense network. And this again highlights the importance of these measurements from a global perspective. A brief example that was shown at the workshop, this plot, is a comparison of different models. The details perhaps aren't important, but essentially what it shows is the quality of the models, of the predictions that can be arrived. The blue colours show where there's good agreement, where the models work well, and the other colours show poorer agreement. And you can see there are large areas of the world where there's poor agreement, areas over Europe and the USA where there's more dense observation systems are better modelled. But I'd also like to highlight two particular areas, one over northern Russia where you can see a series of white dots where the models work very well, and these correspond to the locations of radiosonde stations. And the other is this track between North America and Hawaii where observations are made from aircraft. And again, that allows that area to be modelled well. So we're not just talking necessarily about radiosondes, but measurements made from commercial aircraft can help fill some of the gaps as well. The main outcome of the meeting was that we will be drafting a plan in collaboration with the Secretariat of the Pacific Regional Environment Programme and the Pacific Islands Communication Infrastructure Panel and the Pacific Meteorological Council, and it should be ready towards the second half of next year. This plan will cover the needs for this plan will cover how to improve and maintain the upper air measurements. It will highlight that these are a global good and that therefore the upper air measurement network needs sustained international support. We have to recognise that it is beyond the capabilities and resources of the countries themselves. It's important that this plan and these measurements should be based upon transparent processes and a commitment to free and open sharing of data, because this data needs to be widely used to get maximum benefit from the data. And the plan will have to have a number of considerations included in it. Sustainable funding is vital and needs to be considered in an international context. Communications is an issue that needs to be addressed. Many of the islands have very poor communication systems. One option we discovered were these so-called chatty beetles, which is a short text messaging system using iridium satellite phones, which appears to be a very good and relatively cheap method for many of the islands involved. Other more obvious measures are not, like radios and internet, are not really available in some places. Transport is an issue that needs to be considered in the planning. The distances involved are large. The ships are infrequent and irregular. So this can mean that repairs and necessary maintenance are delayed, and there are periods when sites are not operational. Precipitation is an important parameter, and this will need more national involvement because the situation in the different countries varies quite dramatically, particularly between volcanic islands and atolls. But there are a number of different issues there that need to be considered. But it is important to remember that the national precipitation observations are often insufficient and unrepresentative. Assistance in procurement should be provided. This may be a place where cost-effective solutions, as specified by WMO, can be used. And some sort of joint purchase method could be established, perhaps, to address this. And training it will be a vital part of ensuring sustainability. There are facilities to do this available in both Samoa and in Fiji, so it's something that can be done regionally, but it also needs to be integrated into the plan that we will produce. So the next steps are to produce the plan that will address these issues. We intend to do that well in advance of COP24 and also be submitted to the relevant WMO commissions. It will highlight the global benefits of these observations and the need for continuing support. We need to think about and maybe identify some potential sources of funding. We also intend to continue this programme of regional workshops. In other regions, we're thinking about looking at Africa, and we'll need to collaborate with suitable partners, both globally and locally, to do so. And finally, I'd like to leave you with this picture of one of the Marshall Islands, which I think highlights a lot of the problems. There's an awful lot of water and not much land. So thank you very much.
Thank you very much, Simon. And thank you all the speakers. I think our three hosts this afternoon have provided us with a wide range of speakers, covering a very good description of the different aspects of the problems related to climate. Just a short advertisement. Tim Oakley mentioned the GCOS implementation plan. It's this document here, which is available on the website from GCOS. And that tells you the details of how GCOS is planning its implementation for the observations which are needed for all aspects of climate. So please do go and look at that. I'd like to introduce two more characters to you. These are the secretariats of the two the directors of the two secretariats, one for GCOS and GEO. So firstly, Barbara Ryan, who's the director of the Executive Secretariat for GEO. If you'd like to join us up here, please, for the moment.
Yeah, I'd be happy to. But Stephen, do you want to go to questions?
Yeah, I'll do that in a moment. You do your job, I'll do mine. Please, yes. And Carolyn, please. No, come and sit down, please, up here, both of you. And Carolyn is the director of the Secretariat for GCOS. So I would like to invite those to sum up in a few minutes' time. But before that, I'd like to take advantage of the discussion that we're about to have to allow them to include reference to your comments when we get to the summing up. So that's exactly what we have in plan. So first, we have 15 minutes or so. We have some discussion or questions to the speakers, questions or comments about what you've heard this afternoon. The floor is open to you all, please. Please, in the front here. Let me give you this microphone.
Thank you very much. Luca Lombroso from University of Modena Reggio Emilia, in Italy, not India, from the Geophysical Observatory. One question regarding the possibility to involve private and amateur weather station or weather station from organization that has project in developing country, also using low-cost instrumentation, because the advantage is that more data can be useful also if they are not very precious, like high-quality instrumentation, but that are very expensive often. Thank you.
Thank you very much. So, question. Simon, would you like to respond to that? Okay, you have a microphone.
Actually, that was one of the topics that we discussed in the workshop in Fiji, was low-cost options, especially for looking at precipitation observations. It turns out that I think in the Cook Islands they've done this to some extent fairly successfully. And I believe GCOS has also been involved in doing this in other parts of the world. So I think that's an area that we're certainly looking at, to try and use these low-cost observations where they're sensible and practical. Obviously for the upper air measurements that's a bit more difficult, but where they're appropriate, they're quite a good way of getting the data you need, especially on these small islands where things like rainfall can vary quite dramatically around the different parts of the island.
Thanks very much, Simon. More questions, please, in the front. If you're in the front, you can have a microphone. If you're at the back, you'll have to shout.
Thank you. Rasul from Pakistan. I'm PR of Pakistan with WMO. My question is about radio sound. The recurring expenditure of radio sound. Because of that, the density and frequency of observation is declining instead of increasing. WM is the supervising body for all the meteorological services. And don't you think we should find any solution, a cheaper solution, that recurring expenditure should come down, and the density and frequency of observation, which is required, which is badly required right now, that should increase. So this is a chronic problem. This is not a new one. That's why most of the observations are abundant. Thank you.
Thank you very much. Tim, perhaps you'd like to respond to that.
Well, I can answer from a technological point of view. They haven't come up with a solution to fully take on the measurement accuracy you get from radiosondes. They can't be replaced technologically at the moment, and that's why when you go to any of the big NWP centres, ECMWF, Meteo France, the Met Office, NCEP, they will still say that after satellites, radiosondes have the biggest impact in their model. So the ground-based remote sensing can't replace it at the moment, which is why we're still stuck in this difficulty in funding something which is very cost-wise is quite expensive. It most probably isn't ideal from a fact that we're flying balloons and dropping radiosondes into the sea. So from a climate perspective of dumping things into the oceans, it's not great. But at the moment, it's a technology that can't be replaced. So that's why I think we were, especially when we were in Fiji, we were saying that the funding needs to be more of a recognising parts of the world that the costs are so high that we all need to take some sort of ownership of the cost of flying radiosondes in very remote, isolated locations.
I think that last point I think is very important, that it is the aspect of cooperation which is needed between developed and developing countries. The information is not just for the benefit of the local countries, as you saw from Simon's presentation. It's not just altruism that richer countries are able to support this. It's because they actually get the benefit themselves as well. And if we are to act globally, then we certainly need to be able to ensure that we can set up these partnerships for cross-funding into developing countries. So, next question, Mark.
Yes, thanks for that to all the speakers. Mark Dow, European Commission, Copernicus Programme. I have another question to Simon, so still focusing on that end of the bench. Simon, I know here you focus specifically on upper atmosphere measurements, and so therefore probably I imagine you went through WMO and the NMHSs. But as you start to look at other regions, I think we can imagine, especially in less developed regions, that actually it would ideally be other government agencies and not the NMHSs that would be your potential counterparts. How not being able to take advantage always and systematically of kind of the WMO network, as it were. How do you plan to reach out to these other entities that probably for specific applications in other areas are going to, and specific ECVs and measurements are going to be more relevant, whether it be environment agencies, agriculture agencies, or things like that? How will you deal that once you start doing these regional workshops more systematically, let's say?
Very much. Simon, if you'd like to respond, but maybe I'd like to ask also perhaps Barbara or Carolyn to respond to that as well.
I think that's something to which we don't really have a full answer yet. What we've tended to do so far was to look at some of the adaptation needs as the countries have expressed them, and use that as a basis for looking at what to focus with. I think what we'd like to do in with a bit more run-up and time to arrange these meetings is have a bit more dialogue with the region and understand what they see their needs are as well. I mean, it is worth remembering that if you look at the adaptation needs expressed to the convention, I think of the top 5, there was heat waves, temperature, and the rest were precipitation related, storms, extreme weather events, floods, droughts. So that, in a way, that's what led us to where we were. But it is something that we need to consider furtherly. But I think looking at adaptation is certainly one way of identifying maybe the more important urgent needs.
Barbara, would you like to say something about that?
Yeah, so let me just build on that, because I actually think that Paul's presentation showing the GCOS geo collaboration gave an answer to that. So if many other countries could model what Germany has done, you start to bring a broader suite of agencies together, and they could have been partners in those same workshops. So I think it's this collaboration, not only internationally, what we're doing here, regionally, but also at the national level, so that each of those government agencies, whether it's the Med Agency or the Geologic Agency or the Water Agency or the Biology Agency, are working together to answer some of those same questions in those training workshops.
Thanks very much indeed. So we have one more question over here. Terry.
Yeah. Terry Nakajima's Earth Research Observation Center of JAXA. I'm a little bit, I tried to start a discussion. I don't see that the strengths of the GEO. Because, SDGs and Future Earth, many such initiatives just started. And they tried to measure those many things and try to contribute to the global warming issues. But I think the strength of GEO is that you are constructing the GEO system. But you guys never talk about this kind of things. What is such a quantitative data set, database construction to be contributed to the WMO or COs, whatever? So that kind of more systematic way of mechanism I want to hear. I'm sorry.
I'll invite Barbara to comment on that, but I also have an answer to you as well. I'll come back to it in a moment. Well, my answer to that would be that we've had a very good example today with Paul again in his presentation of what the power of GEO is and what the value of GEO is. And there was the discussion about GFOI, the Global Forest Observation Initiative. And that's an initiative to use primarily satellite data, but also in situ data, to support countries in their applications for payments through the World Bank for RED Plus funding. And just imagine what that program, which has been running now for about 6 or 7 years, had 5 partners. And that was the US, Norway, Australia, FAO, UN Food and Agriculture Organization, and CEOS, the Committee on Earth Observation Satellites. Those 5 partners were the original 5, and there's a couple more now. And the GEO is the only place where those 5 parties would actually speak and talk to each other. There's nowhere else in the world where they would be sitting around the table with equal status and equal ability to take part in a project. And that really is the unique value of GEO. There's another issue about how you bring the data together in GEOS and a system of systems, and that's a more technical data infrastructure question. But from a policy question and from the value for me of GEO is that we're able to provide a forum where over 100 member states and over 100 technical organizations can come together without any prejudice and have an equal status in terms of a discussion. And that is a very valuable contribution, I think, and for me, what GEO is really most valuable for. But Bob, you probably have some other ideas.
Well, I'll add just a couple things, but now I am going to dip into what I would have said at the end of the session. And again, citing Paul, because he really talked about the need for accessibility and interoperability. of that data. And so, again, it's not just atmospheric and oceanic and terrestrial data, but from all those sources, whether it's space-based or ground-based or marine-based. And then I thought some of the presentations did a great job of showing filling gaps with either aircraft data or ship data. You know, we didn't talk a lot about citizen science or citizen sensing, but that came out of a breakfast discussion this morning with our geocontacts in Switzerland, Jose Romero, and I think we'll see more of that. The actual infrastructure that we have has more than 400 million resources, and if you specifically talk about the linkages with WMO, all of the information in the WMO information system is discoverable and accessible also through the GIS infrastructure, but also WMO is one of the largest users of the GIS infrastructure above and beyond their WMO information system, because there is a need for other kinds of data that currently aren't coordinated through the traditional meteorological agencies. So thank you very much for your comment, but I think you're absolutely right. While this venue wasn't specifically targeted at the infrastructure aspects of GEO, international collaboration is just essential for that.
Okay, it's time. We've perhaps got one more question, maximum. Okay, there's one at the back there in the center. I think there's a microphone. Last question, then I'll ask Barbara and Carolyn to sum up.
Thank you. Ravin, Fiji delegation, Director Meteorology. When we see the GCOS is Global Climate Observing System, and climate consists of atmosphere and oceans. With the presentation heavily on the ocean observation, land observations, and the ocean observations have been missing. Would you please highlight if there is any implementation plan on ocean observations or enhancing and sustaining ocean observations? Thank you.
Okay, well, I think I'll pass that to Carolyn, who can answer that, I'm sure, very effectively.
Yes, thank you. So for our implementation plan, climate is actually also focusing on the oceans. So we're always looking at the three domains, as we say, which is the atmosphere, the oceans, and the land. And this is actually why we have three colors in our GCOS logos. So if you go to this sort of big booklet, we have 1/3 of it is only dedicated to ocean observations. In particular, and this is maybe how I would like maybe to also wrap up what I've seen here, in a way we heard a lot. So if you're thinking about taglines, so in GCOS we are educated currently in how to communicate better. So our advisors told us we should think in taglines. So I came up with 3 taglines here. And one is actually might be a response to you one. This is "We are family." And that shows actually the partnership here. And what we have achieved, so there are different sort of mechanisms, there are different systems around the way GEO is working on the sort of more ministerial level, and the way GCOS is working, which is more on the partnership between different United Nations agencies and non-governmental organizations. So we all bring along different partners, so we are family. And then the second tagline is actually, and that is sort of based, we haven't really touched upon what our Finnish expert had told us about integrating carbon observing systems and the greenhouse gas missions from Japan. This is actually seeing is believing. So if these projects like ICOS and the GOSAT initiative wouldn't show what is going on, we wouldn't believe that something is going on in our system. So we are family, seeing is believing. And then again, my colleagues from the GCOS Secretariat, back to the roots as well. So we have to sort of work on the grassroots level. And coming back to we are family, these partnerships, I think would be really great if rich family members would support the poorer family members in future. I would be extremely grateful for that. Thank you.
Thank you very much indeed. I don't know whether, Barbara, you'd like to add any further comments at the end here? You had the opportunity, yes? I'll just finally wrap up then.
All right. Yeah, thank you very much. Let's see, we talked about, well, of course, the role of international collaboration, and then this point about accessibility, interoperability of data. But I think what I saw from each of these panel presentations is that there really is just increasing capability. You know, if you look at either the spatial or the temporal frequencies that are being increased from satellite observations, so time and space, but also the actual frequencies that are being measured from space is really important. But when we looked at the kind of when this finally reaches the ground, there still are substantial challenges around the world. So whether it's the small island developing nations that we heard about at the end, or any of our agencies that are really in need of additional resources. I think one of the challenges that we have, and there was some reference to it early, is the importance of broad open data. Not only data that's collected by the rich governments of the world to share with those lesser well-off governments, but data from those lesser places, this was the ECMWF quote that we heard about, is important for those global models. And we still have governments around the world that are not sharing data. And that brings us broadly and openly. And then I think that brings us to really the last point that I took from this session is that it's really important to close the gaps between observations and users. But if the data isn't being shared, then it's very difficult to close that gap. And I would argue that maybe some of our agencies are in some financial problems because users don't know how relevant and important their information is. And so we can go forward and advocate on behalf of our organizations on how good our data is, but it's way more powerful to have our users come in and speak on our behalf. And so if those users don't have to pay for that government data, I think it would actually have a much more positive benefit long term. And then the only other thing, because again, with Carolyn next to me, the role that GCOS and the entire GCOS community, certainly led by the Secretariat and the Steering Committee, the role that these essential climate variables have played is absolutely essential. Not only did it marshal the scientific community to come together, but I would argue it was a forcing function on bridging observations to users, because as soon as the policy group of UNFCCC and SBSTA started citing those ECVs, this starts to close the gap. And so what we are seeing in other communities, whether it's the essential biological variables that the Convention on Biological Diversity is looking at, or essential ocean variables that UNESCO IOC, many of which are GCOS ECVs. This, I think, we're going to look back at this 10, 15 years, whatever the development of the ECVs have been, and really see this as a substantial change in this case, climate monitoring, but I think just the whole study of Earth observations as we go forward. And I think we saw pieces of that throughout each of the pieces today. So thanks.
Thank you very much, Karen. So finally, I'd like to thank all our speakers today again, and our summarizers here, for the very broad perspective that we've had on the different types of observations. And there's a lot of discussion about whether this is a GCOS, a GEO, or is this CEOS, or is it WMO, or is it IGOS, or is it IOC who's responsible for this? Let's not worry about the labels. One of my favorite sayings is that it's amazing how much you can achieve if you don't worry who gets the credit. Let's worry about what we have to do, not who gets the label for it. Thank you very much. And I think, by the kind generosity of our Japanese colleagues, I believe we have some small refreshments available outside now. Thank you.